One of the things that I really, really like is I'm not very good at remembering equations. It's just life is too short. So sometimes I'm confronted with converting things from one thing into something else. So we talked about this problem with the miles and the kilometers. How many 1 mile equals?
1.6.
Yeah, 1.6, I think it's 1.68 kilometer, right? Something like that. Might be wrong, but... by the way, what does kilo stand for? Kilo. Kilo? Loud? 1,000, yeah? I can write 1,000 as? Grams. No. I refuse to write 1,000 as grams. I have 3 grams in my bank account. I wish. I can write that in a scientific notation as K. And that is 1,000. And that is 10 to the power of 3, exactly. Yeah? What's the next unit up? Kilo. Not meter. What's the next unit? Kilobyte? Mega. Yeah. That's 10 to the 6. That's right. And a million. Yeah? 1,000, 10,000, 100,000, a million. What's next? Mega. Giga. Ten to the 9. Next. Tera. Ten to the 12. Okay. Let's go in the other direction. So we have the base unit. So that could be gram or meter or something like that. Yeah. What's the next down? From gram into milli? In terms of zeros, it is 10 to the minus 3, and that would be 0.001. Do you actually know how you get to these, say, this number 3 with this one here? Huh? Say again? Yeah, but how do I know that it's minus 3? I can move the decimal place. Have you seen this trick? Yeah? Where you say, all right, I've got my decimal place here. And for all international students, please, 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 make sure in the UK it's a dot. Yeah? In Germany, for example, you would write it as a comma. It causes terrible confusion. We are here. It's still before Brexit. So it has to be a dot. Yeah? Dot. And I move it. Move it, move it, move it. I move it 1, 2, 3. I move it here. So it would be 1 times 10 to the, because I move it in this direction, it is minus. I moved it 3 times, so it is minus 3. Yeah? What's next down from milli? Micro. It's abbreviated with the Greek letter mu, micro. Sometimes computers, I can't do a micro due to my program, so I usually abbreviate it with a U, but hopefully you understand what it means. So this would be 1 times 10 to the minus 6. Micro. Next one. Nano. N. 1 times 10 to the minus 9. Next one. Pico. P. 1 times 10 to the minus 12. Next one. Femto. One times 10 to the minus. Next one. Atto. 1 times 10 to the minus 18. Okay, good. So we've established that, yeah? Okay, so let's go back to our problem. 1 mile, 1.68 kilometers. Let's say I want to convert 5 miles equals how many kilometers? And I know that 1 mile equals 1.68 kilometer. So of course it would be nice to have an equation to deal with that, yeah? But I told you I'm lousy at learning equations. This is where this fantastic system of units and dimensional analysis comes into play. And you can do that actually for any kind of conversion. And that's really the beautiful thing about that. So the first thing that you do with this dimensional analysis is you say, what is the unit that I'm looking for? What is the unit that I'm looking for in this example? It is kilometers, yeah? And I write this unit down, kilometers. This is what I want to have, yeah? Okay. Now, here comes a little line. This line, I treat this almost as a fraction line. Like 3/4, you have this fraction line in there. That's how I start. Now the first step is I try to find something with the unit that I want in my givens. Do I have anything with the unit kilometer in my givens here? Which is? 1.68. And I write it so that the unit that I want is on top of the line. So I write it 1.68 kilometers. And the mile is down here. Yeah? You see the principle? So, what I now have is, I have already my unit that I'm looking for, the kilometers, in the right place. But Sod's law, I've got a mile underneath. So, how do we get rid of this unit, this one here? How do we get rid of this unit down here? Well, we multiply it by something so that this mile disappears and cancels out. Do I have anything with a mile there? 5. 5 mile. Do I have anything underneath? No, don't have anything underneath. What you see is that the unit, the mile, cancels out. Yeah? So what I have done now is I got rid of the pesky mile, and all I have left is 1.68 kilometer times 5. And I can do that in my head. That is 8.4 kilometers. Easy. Got it? Okay. Here is one for you guys. For you to try out now with this method. That's the sun. That's the Earth. I know my drawing skills could be improved, but hey. Now, the light from the sun to the Earth takes pretty much about 4 minutes. So actually, when you see the sun coming up, it already took the light 4 minutes to come here. So it's 4 light minutes away. And the speed of light, anyone knows that?
3 times 10 to 30.
3 times?
10 to the power of, remember, the 8. A lot faster than that.
Bananas. You are absolutely right. Actually, no, you're not. You're absolutely wrong. It's the unit thing, isn't it? Okay, don't worry about it. The speed of light is 300,000 kilometers per second. How far is the sun away in kilometers? I write it like that. How far is the sun away in kilometers? Over to you guys. I don't know, actually. Looks about right, yeah?
Yeah.
So I've seen already a few solutions. How do we do that with dimensional analysis? What is the unit that we are looking for? Sorry? It's kilometers. Do we have any kilometers there? Yeah? What is it? 300,000. Can I actually write this as a 10-2? How would I write this? I do a point, a decimal point after the last significant zero. So it would be 1, 2, 3, 4, 5. Yeah? 3 times 10 to the 5 kilometers per second. Excellent. I've got my right unit here on top. Right? But I have seconds. Need to get rid of the seconds. Sorry? Ah, okay. How do I do that? Wait. What do I know? 1 minute equals 60 seconds. Yeah? You're absolutely right. But I wanted sort of the additional step in it. So do I have anything with seconds in it? Yes, that's what I just did. So I've got 60 seconds in a minute. And you see, what I can do is, hasta la vista. The seconds cancel out. Which leaves me with another problem. I've got minutes now down there. Oh, bum. Do I have anything with minutes in it? 4. Times 4. Minutes. The minutes cancel out, and I'm left with just the unit that I'm looking for. How cool is that? Right? So I have 3 times 10 to the 5 kilometers times 60 times 4, 1227 point. So equals 7.2 times 5, 6, 7, 10 to the 7. Is that right? Have I calculated it right? Oops. Times 7 kilometers. Got it? This is the principle of dimensional analysis. Right. Here's another one. And you don't need to know what these substances, what these units actually are. Let's say we have, for example, we haven't touched on that yet, but we have a substance substance is defined by what is called a molecular mass, which is 155, let's call that gram per mole. Whatever mole is, we don't care at the moment. Right? And we want to know how many of this mysterious mole is in 3.1 gram. We don't know what mole is. Can we still answer this question? Yes? How do we do that? What are we looking for? What's the unit that we're looking for? Mole? Excellent. Have we got something that has mole in it? Whatever mole is. Yeah, we have 155 gram per mole, although the mole is down there, but it doesn't matter. We can look at it from the other side. We can say 1 mole, 155 gram. Yeah? You get it? I've got my mole in the right place. So mole is good. What do I have to do? Get rid of the gram down here and multiply. Multiply it by something that has gram in it. Do we have anything with gram in it? 3.1 grams. What happens to our units? They cancel out. And I have left 3.1 mole divided by 155, which is 0.02. What? Mole, thank you. Even you, without knowing what a mole is, whether you can eat it or you can, polish the furniture with it or something, you could solve this answer. You could solve this question with this dimensional analysis. How cool is that? There are other ways to do it, but I really prefer this way. The reason why I prefer that is because it, by default, gives me the right unit. Here's another one for you, which was in one of the tests that I put up. I have 135 milliliter, and I want to know how many microliters that is. So first of all, what do we know? We know that milli, what does that stand for, milli? 10 to the minus 3. So 1 milliliter equals 1 times 10 to the minus 3 liter. Micro? Loud? Minus 6. 1 microliter equals 1 times 10 to the minus 6 liters. Right, so can we do a dimensional analysis? What's the unit that we are looking for? Microliter. Let's write that down. Do we have anything with microliter in it? Okay, we have 1 microliter. We write that on top. Oops. And the rest down there. 1 times 10 to the minus 6 liters. Yeah? Okay, the microliters are good. We've got them. But the liters, I don't want them. What do I do? Do we have anything with liters in it? Yes, it is 1 times 10 to the minus 3 liter, and we have 1 milliliter. What happens to our liters? Right? What's the problem? I've got the milliliter. Have we got anything with a milliliter in it? 135 milliliter. What happens to the milliliter? Hasta la vista. Right? So I have 1 microliter, 1 times 10 to the minus 6, times 1 times 10 to the minus 3, times 135. Yeah? What's the unit? It's still microliter. We are good. We haven't lost it. My wife would argue that I've lost it a long time ago, but that's a completely different story. So how do we deal with that? Well, we have something with a negative exponent down under. And we know that we can write 10 to the minus, let's say, x. That's the same as 10 to the x. You can think of this fraction line as a minus sign. And minus times minus is plus. So we can write this as 1 times 10 to the 6 times 1 times 10 to the minus 3 times 1.35. How can I write 135? Times 10 to the 1, 2. 10 to the 2. Yeah? Make sense? And now we have exponents. And we know that we can deal with exponents if they have the same base, which is 10 here. We just simply can add and subtract them. So we can write 1.35 times 10 to the 6 minus 3 plus 2 microliter, still the microliters. 6 minus 3 is 3 plus 2 is 5. So we have 1.35 times 10 to the 5 microliters. Do you agree? Actually, this was one of the questions in the metric system quiz that caused a lot of headache. And I was so pleased. Because at least I could show you how it works. Are you happy with that? So what I would suggest to you is when you have time, look at the metrics quiz, the metric system, and also, what else could I, well, what do you feel comfortable with? Okay? I'm not going to torture you any longer. You've got half an hour for your next lecture, and I shall see you all tomorrow, bright-eyed and bushy-tailed. Okay? Have a lovely evening. Be good and don't do anything I wouldn't do.